In this section, you learn about the rules of exponents, and probably you've seen some of these before. And it's not all the rules of exponents. We're just going to look at some of them for right now, and including those dealing with negative numbers. We'll avoid fractions as exponents and other things like that for the time being. Okay, well, I think it's worth a little discussion as to what exponents are. And so what is an exponent? Well, an exponent is a subscript number above a base. And so this would mean, what, 2 to the 5th power. We interpret this as a product of 5 2's. Multiply 5 2's together, and we get 32. Now, as far as a little bit of terminology here, the superscript number is the exponent, and this number down below is called the base. So it's kind of nice to know that's the base. When you learn about logarithms in a future math class, then actually this math class at the end we talk about logarithms, the base comes into play. All right, exponents are a purely man-made construction. It's not a true mathematical discovery. It's just a convenience of the language, so we don't have to write repeated multiplications. And it's very, very useful, not just in math, other areas. For example, in computers, you've all heard of kilobytes or megabytes or gigabytes. A kilobyte ends up being 2 to the 10th power number of bytes. And so that would be a product of 10 2's, and it turns out that that's 1024. So it's called kilobyte. It's close to 1000. Kilo is the sort of the metric term for 1000. It's not exactly 1000 bytes, but it's close. And so 1 megabyte is 1024 kilobytes, and so on and so forth. Your computer probably has 24-bit color for its monitor. If it does, then it takes 24 on and off switches to record the color for every little pixel on your screen. And there's probably about 1 million pixels on your screen, computer screen. So each pixel requires 24 memory slots turned on or off. And the total number of colors, since they can be on or off, there's two positions for each memory location. It turns out the total number of colors possible on a computer is to the 24th. That's 24-bit color. And it's an enormous number to write out, 24 2's in a row. No one wants to do that. So we learn about exponents. It's very handy to work with. By the way, it's 16, I worked it out here a minute ago. It is, I guess I lost it, 16,777,216. So that's probably how many colors your computer monitor has, in case you're wondering. And it's not clear how many colors humans can see. Most people seem to think humans see fewer colors than this. Some people conclude they can see more colors, but it generally covers about what we can see. Okay, so back to work here. Now I just make a little observation. The exponents, and I don't know who developed these. It must have been, several hundred years ago at least, developed the idea of exponents. And but it's sort of an extension of another idea that we've found very useful much earlier than exponents, and that is multiplication. Because, for example, what is 5 times 2? Well, 5 times 2 means to add 5 2's together. So multiplication is a repeated addition. And exponentiation is a repeated multiplication. So in that sense, they're kind of similar in that respect, that multiplication is a short way of doing a lot of repetitive additions. And by the way, in case you're wondering, division is a repeated subtraction. And so I'll leave it at that. Now I want to talk about one other thing in this little video, and this is a mistake that people will make. Another one of those common errors, and don't fall for the trap. So let me give you this example. minus 7 to the second power. Or we might say that's negative 7 squared. All right, now what do you think it is? You're probably wrong. Okay, I know students, and you probably said, well, that's equal to 49. No, it's not equal to 49. Yes, and I do know that 7 times 7 is 49, and negative 7 times negative 7 is 49. So let's think about that. If we had negative 7 times negative 7, the negatives cancel, we would get positive 49, wouldn't we? And wouldn't this be the same as negative 7 parentheses squared? Because I'm repeating this multiplication of these two parentheses, it's the parentheses squared. That's okay. Now what's the difference between these? Well, there's no parentheses here, and it turns out the exponent only affects the base. It doesn't affect the negative unless you group the negative inside the parentheses. And so now that doesn't convince everybody that that's the way it ought to be. Some people object to this, saying that this should be negative 7 times 7, which is negative 49. So let me offer you some more persuasion on this, why that's got to be, this one has to be negative 49. How would you handle this problem? 0 minus 7 squared. All right, well, the order of operations say that we're supposed to do the exponents before we subtract. So we're supposed to work the exponent. 7 squared is 49. And then we subtract from 0. 0 minus 49 is negative 49. Okay. Well, if I were to subtract 0 from all sides of this equation, it wouldn't change the problem, would it? Subtracting 0 doesn't change anything. I could just erase it. Negative 7 squared is negative 49. So this is true because of the order of operations. And so again, it's one of those common errors. People will look at this and say, oh, it's positive 49. No, it's not. And so be careful with that one. It's part of the language that is a little tricky that we've developed through the years. And this is just a little piece of the language that people will make a mistake over.